Good morning, student. Today's session on the new chapter Arithmetic Progression. So far, we have studied quadratic equation. So just recall that, and whatever the doubts you have, you call me. So instead of putting that in a comment in a Google class, instead of that, you call me. So next week onwards, we have one session of doubt clearance through Google Meet. Okay, we will solve so many problems, or we will discuss about the problems what you are facing during this online session. Okay, now today is arithmetic progression. Remember, next week after the session, Wednesday our session is over. Next Thursday we have a Google Meet direct discussion. Okay, so all you should download that Google Meet app and then get ready for your doubts. Now next I am going to the chapter Arithmetic Progression. So these are the very important chapters and lengthy chapters. Also it contains a lot of marks, that means weightage of marks in this chapter. Clear? Now first, what is an arithmetic progression? So first we should know that. So here I am writing some numbers. You just go through this: 5, 10, 12, 100, 25, 1000, okay, 14, 16, 8. This is the one set of numbers. And here in the second set of numbers we have 1, 8, 28, 76, 200, 1000, etc. etc. And third one we have this 2, 4, 6, 8, 10, etc. etc. or 1, 4, 9, 16, 25, etc. etc. 3, 7, 11, 15, etc. etc. Here on the board you are seeing 3 sets of numbers. Now observe that these 3 sets of numbers, and what you are observed in these 3 sets. What is the difference between these 3 sets? Guess? Now here in the first set, the numbers what I am written, it is in the haphazard way. That means there is no order at all. Okay, here there is no order. Now coming to the second one. In the second one, you have an order. The numbers what I have written, it has some order. So what is that order? It is written in ascending order. The numbers are written in ascending order. And in the third one, observe the number, they are written, these 3 are written in an order, and also they have some rule. So see, those set of numbers which are written according to some rule. So rule means it should be in order. Okay, so definite rule and order. Those set of numbers what you are writing, that is called sequence, or they are called as progressions. The set of numbers, they are called as progressions, sequences. Clear? They have a sequence form, but here it is not in a sequence. Here also it is not in a sequence, but it has sequence. Okay, so a sequence is nothing but the set of numbers which are written according to some definite rule. So definition of a sequence is what? Set of numbers which are written according to some rule. Okay, now look at this. What is the rule? What is the definite rule here? Here one number and its next number. What you are writing? That is increasing by 2. In this, natural numbers, squared of natural numbers you are written. 1 square, 2 square, 3 square, 4 square, 5 square. So just like n square, where n is a natural number. And here is the rule is the one and the next one is increased by 4. That is the rule. So like this, so many rules you can write. Clear? So there is a one question for multiple choice. They will give the rule. Then we should find out the first four numbers or terms. Here the numbers which are written, they are called as terms. Terms of the progression, or it is called as a sequence. Terms of the progression or sequence. Clear? Here also 1 is a one term, 4 is a term, 9 is a term, 16 is a term, etc. etc. Here the term, what the first one is written, they are called as a first term and it is denoted by A1. First term. And here is the second term, it is denoted by A2, A3, etc. 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 We don't know the last term, so it is denoted by AN. This is called as a nth term. Nth term. Here AN, or you can write it as a TN. You can use any one. TN or AN. TN or AN, what they are called? They are called as the nth term of a sequence or a progression. Clear? This is what? The definition. I am writing the definition on the board. You just see that. Are you clear this? Now. Some numbers arranged in a different order. In a definite order, according to a definite rule. According to a definite rule. Definite rule or set to form a sequence. Set to form a sequence. Okay. Now here in this the term, the general we are writing this as A1, A2, A3, A4, etc. 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 The last one, it is called AN or TN. See here A1, or it is also called as a term 1, term 2, term 3, term 4, etc. etc. So here in some books they are given as a T1 and some books it is given as a A1. So always use A1, A2, A3 and remember that that is the term of the sequence. Clear? So these are the definition of a sequence. Now when this sequence, the terms of the sequence are arranged, the terms of the sequence are arranged according to some rule. That is what the definition of the sequence. If in this sequence, if the difference between any two consecutive terms, is a constant, then it is called as arithmetic progression. Here the sequence are progression. Clear? See, it is called as a sequence or progression. Sequence or progression. So here, according to the definition, the difference between any two consecutive terms is constant. So here, the progression A1, A2, A3, A4, etc. etc. Now, the difference of two consecutive terms means like this: A2 minus A1. This should be equal to A3 minus A2. This equal to A4 minus A3, etc. etc. So the difference between any two consecutive terms of a sequence is constant. Then that sequence or the progression is called an arithmetic progression. Clear? See, these are the examples. Just recall the example. In that examples, here 2, 4, 6, 8, etc. etc. This set of number is called arithmetic progression, because 4 minus 2 is 2, 6 minus 2 is 2, 8 minus 2 is 2. Here the difference between any two consecutive terms is a constant. So this set of numbers are called as arithmetic progression. Now look at the second example of the sequences 1, 4, 9, 16, etc. etc. If you are taking this, 4 minus 1 equals 3 and 9 minus 4 equals 5. Here itself these two are not equal. 3 not equal to 5. Therefore, this set of numbers which are written, they are not in arithmetic progression, but this is a sequence because it is written according to some rule. So this is a sequence but not an arithmetic progression. Therefore, we can conclude that all sequences are not progressions, but all progressions are sequences. Clear? So this is what the definition of arithmetic progression, right? The next is we know the definition of arithmetic progression, right? So in this we should know that to say whether the given set of numbers are in arithmetic progression or not, we should find out the common difference. See here what the difference we got, that is called common difference, and it is denoted by D, and the formula is succeeding, S-U-C-C-E-E-D-I-N-G, succeeding term minus preceding term. Preceding term. So to find the arithmetic progression common difference, so you can write it as CD, common difference. To say that the given set of numbers is an arithmetic progression. So first thing is you should find out the common difference. For that, succeeding term minus preceding term. Okay. Now, if the arithmetic progressions terms are represented by like this: A1, A2, A3, A4, etc., etc. This is called the terms of an arithmetic progression, right? Then its nth term, to find the nth term. So this is the terms of that. So we are finding or we are writing the general form. General form of an AP. So first term A. So according to the definition, they should have the common difference, right? So for this A, if you add 1D, it becomes A plus D. Now to this add one more D, we are getting A plus 2D and A plus 3D, etc., etc., like this. So this is the general form of an AP. Here, according to the definition, the AP, the terms, they should have a common difference. That means the constant difference. Then only it is called an arithmetic progression. So according to that, here the general form you can write like this: A, that means there is no D. Now to write its succeeding term, we should add D, common difference, to this. Okay, so like this we will get. Now, so here according to this, now nth term is represented by AN. Now how to represent AN? Now, or how to write the nth term of an AP like this? Okay, now look at carefully. A1 is what? A. Is there any D? No D. So I am writing this as A plus 0 into D. 0 into D means 0. So A plus 0 is 0. Again I am writing this in the form of A plus 1 minus 1 into D. Look at this, A1. So 1 minus 1 is D. Right. Now A2 is what? A plus D. So this is the second term. First term, second term, third term, fourth term, etc., etc., nth term. So A plus D. That means A plus, how many D is there? 1 D is there. So I am writing that as 1 into D. So I am writing this as A. Here is 2. So I am writing 2 minus 1 into D. See, 1 D is there. So 2 minus 1 into D is 1 D. Similarly, A3 is equal to A plus, how many D is there? 2 D is there. So write 2 D. That is A plus 2 into D. That is A plus 3 minus 1 into D. In order to get 2, we should subtract 1 from 3. So 3 minus 1 into D. Similarly, A4, what you can write? A plus 3 into D. That is A plus 3D. So A plus 4 minus 1 into D. Are you following? So like this, if you are extending this, etc., 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 A-N. So here also I am writing this as, see, look at this, A is common, right? Plus is common, and here 1, 2, 3, 4, etc., etc. Look at this, 1, 2, 3, 4, etc., etc. n times. So here also we can write this as n. Here is minus, 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 minus. 1, 1, 1, 1, 1, 1 into d. So this is the nth term of an AP. Nth term of an AP is given by a plus n minus 1 into d. This is the nth term. Clear? So, what is the general form of an AP? A plus D, A plus 2D, A plus 3D, etc., etc. AN is equal to A plus n minus 1 into D. Clear? So, how we get this A plus n minus 1 into D? Go through like this. Clear? This is a very, very important formula. We are make use of this in solving the problems. Right? Now, next thing is they are providing the AP. Then we have to check whether the given set of numbers are in AP or not. So for that we should find out the common difference and we should check whether the differences are same. Now in any AP, in an arithmetic progression, to find succeeding term, and to find succeeding term we should take it as a preceding term plus d. To find the succeeding term of any term, we should add common difference to the previous one. So it is denoted by, say like this, a n plus 1 is equal to a n plus d. So a n plus 1, that means a n is a term, its preceding one next to that is a n plus d. Similarly, to find the preceding, see these are the formula, very, very important formulas. So you may expect for multiple choice. See, preceding term is equal to succeeding term. In that you should subtract common difference. That is a n minus 1. Minus 1 is its preceding. So this is a n minus d. Succeeding minus. So to find the preceding term, you should subtract common difference. To find the succeeding term, you should add common difference to the given term. Clear? So these are the very, very important formulas. Right? Then next we will work out some problems on that. I have written the definition of arithmetic progression. A progression in which each term differs from its preceding term by a constant is called an arithmetic progression. Okay, in the previous definition I have written the progression or sequence. What is a sequence or progression? Here this is the definition of arithmetic progression. Right. Now let us take it the first question based on the definition of arithmetic progression. Now look at this. Show that ST stands for show that the progression, what the progression they given is an AP. Now we have to show that this is an AP and also write its first and the common difference. So first and the common difference. So how to do this? The simple one, solution. So write down this. First A1 is what? 8 and A2 second term is 11. A3 is 14. A4 is 17. A5 is 20. Right. So according to the definition, a progression in which each term differs from its preceding by a constant. Now I am writing this A2 minus A1, that is equal to 11 minus 8 is what? 3. Now next A3 minus A2, that is 14 minus 11 is 3. And next A4 minus A3, that is equal to 17 minus 14, that is also 3. Then A5 minus A4 equals 20 minus 17 is 3. Now look at these. These are the difference. So they have a constant difference. They differ by a constant. The terms are differ by a constant called a constant difference. So the common differences are all same. Therefore, common difference are same. Therefore, given progression is an AP. Therefore, the given progression is an AP. Now, first term A1 is equal to, the first is a 8 and common difference D is 3. This is what that has. Clear? How to show the given sequence or the progression is an AP or not. So this is the way. Now next, clear this? Understood? Now the second one. What the numbers they are giving, we should check it whether it is a arithmetic progression or not. Yeah. Now, second question, question number 2. Now look at this. 2, 4, 8, 16, 32, etc. etc. Is this an AP? So how to check this? Now let us take this as A1 equals 2, A2 equals 4, A3 equals 8. Now just take two terms, A2 minus A1 equals 4 minus 2, that is equal to 2. Then A3 minus A2 equals 8 minus 4 equals 4. Therefore, 2 not equal to 4. It means that common difference is not same. Therefore, given progression is not an AP. Understood? So this is how to verify whether the given progression is an AP or not. Clear? Now let us take question number 3 with negative ones. I'm taking question number 3 like this: 5, 3, and this is 1. 1, then 2 is a minus 1. Okay, minus 2, minus 3, etc., etc. Now we have to check whether this progression is an AP or not. Now A1 is 5, A2 is 3, A3 is 1, A4 is minus 3. A3 is minus 3. Right. Now, first difference, D1 is equal to what? A2 minus A1, that is 3 minus 5, that is equal to minus 2. Now, second difference, D2 is what? A3 minus A2, that is 1 minus 3, that is also minus 2. Then D3 equals A4 minus A3, that is minus 1. A3 is A4, 1, 2, 3. A4 is minus 1. A5 is minus 3. A4 is minus 1, A3 is plus 1. So minus 1 is minus 2. Then D4 is equal to A5 minus A4, that is minus 3. Minus of minus 1 equals minus 3 plus 1 is minus 2. So therefore here D1 is equal to D2 is equal to D3 is equal to D4 is equal to D5, etc., etc. Therefore given AP, given progression is an AP. Understood? So this is how to check the given progression is an AP or not. See, this is what the chapter beginning. So go through the videos twice, thrice, and studies well. Go through your textbook also. Refer the textbook and read the textbook. What is the given extra information? You make your own notes and write down in the classroom. So whatever I am doing on the board, you should write down that in the classwork then and there itself. Also, after completion of that, each worked example problems also you should write down in the classwork. Right? So next Thursday we will meet in the Google Meet. Right?